Okay, hello everyone. Today we are going to study the second method for finding y particular, which is the particular solution for a second order differential equation. This exists in section 4.6, which is called variational of parameter method or variational of constant or variational of constants. Now let me just remind you with our problem. Our problem is you have y double prime times a plus b y prime plus cy equal f of x. Last time we said the solution or general solution for such equation is y equal to y homogeneous plus y particular. Now we know how to find y homogeneous. You find two solutions, or you change the equation to a homogeneous equation. You change it also to a quadratic equation, and then you find two solutions, y1 and y2, and then you multiply the first with a constant c1 and the second with a constant c2, and then you combine you add them to get your y homogeneous. Now last time we studied how to find y particular, and we said the first method will be kind of guessing the solution when y homogeneous we know how to do it. For y particular we said method 1. I give you method 1 last time. It is kind of guess the solution, guess y particular when f is nice, yeah, and then use indeterminate coefficient method, yeah, to find your constants in y particular. And we know last time what are the nice functions. So either sine beta 1x, cosine beta 1x, either one of these or a linear combination of them, or exponential k1x, or polynomial p of x, or any multiple of them, or any linear combination of them. Then these are the nice functions, and you can guess the solution because these functions are repeating themselves or keeping their structures after you differentiate them. Now let's go with method 2. Here is method 2. Now this is method 2. This is method 2. Now this method 2 is telling you that y particular here, y particular can be found in a different way. So here is y particular. This y particular in method 2 can be found in a different way. Let me first write for you y homogeneous, and then we talk about y particular. Y homogeneous is c1 y1 plus c2 y2. Yeah. Now your y particular now will be, now it is called variational of parameters or variational of constants, which means these constants should be changed to variables. So changing the constants to variables, then I'm going to change this c1 to a function. I will call it v1 of x. I will change this to v2 of x. And then here you're going to have the y1 again and the y2. So kind of y particular is built in method 2. Y particular is almost built in the same way that the homogeneous is built, except the constants here should be changed with functions. Now can you tell me how you're going to calculate v1 of x? I'm going to tell you that v1 of x has a formula. This formula is the following. There is a minus sign here, and when you have v1, then you use the second solution for the homogeneous y2, and you multiply that with the right hand side of the equation times f of x divided by the coefficient a here, a, and then times the Wronskian of y1 y2. After you multiply, you get a function, you divide by a function, and then you get a function of x. You need to integrate that function with respect to x to get v1. And also for v2 of x, you need to memorize those formulas. Yeah, it is now you use y1 and multiply it with f of x, divide by a times Wronskian of y1, y2, yeah, and then dx. So this is the way of building v1 and v2. After you get these functions, you just put them there, right? You put them here, and then you get what? The y particular. My advice here, not to add any no constant of integration. When you integrate here, don't add any constant of integration. Don't add constants of integration. Why? It is simply because y particular should has no constant of integration, and y homogeneous should contain the constant of integration. So the special about this part, it has the constant of integration. The special about this, it has no constants of integration. Now there is one more thing I'm going to tell you as a remark here. What if you change this to functions of x and cx? Well, the variational of parameter will work. So in this case, you must use variational of parameter. So this means that the indeterminate coefficient method will not work, and you start putting here a of x and a of x there. Yeah, so variational of parameter is working whether here you have constants or not, but indeterminate coefficient, the old method will work only for constant coefficients. So do we need f to be nice? So this method also, this method will work even for not nice function f of x. So I'm going to say method 2. So method 2, which is variational of constants, works for number 1, f of x, nice or not nice, any f of x, nice or not nice. You know, by nice we mean here sine, cosine, and exponential and polynomial, and their linear combination or a multiple of them. When I say not nice, I mean tan beta 1x, for example, secant beta 1x, maybe log k1x. Maybe if you divide something like sine x over, I don't know, 1 plus cosine x, any combination of them, but here we have division, yeah? So we said nice means multiplication or linear combination, but here we have division. Then for this reason, you cannot use the guessing method. Then you need to use variational of constant or variational of parameters method. Number 2, it will work also when a, b, and c are function of x. So whether they are function of x or not, then this method will work. So you're gonna tell me if this method is the more general method, then why you don't teach us this method from the beginning? So why you keep it till section 4.6? So number 3 here, there is so here one remark, if you like, remark. One problem with this method, one problem in this method is that V1 and V2 integrals, V1 and V2 integrals are sometimes hard to evaluate. I will show you this. So the problem that why I didn't give you this method from the beginning and just ignore the indeterminate coefficient method, which is guessing the y particular, is that this method, even it is working for any f, for any coefficient, it has one problem. The problem is sometimes these integral v1 and v2 are very hard to evaluate. So if you can avoid very hard integrals, then why you don't go with guessing and indeterminate coefficient method? I will show you. I will explain this by an example later. So let me now go with an example. Here's an example. It says find the general solution for the following equation. What is the equation? Let me go with something like y double prime plus y equal. Now let me go with secant x. Yeah. So here is your f of x, right? Let me just this is your f of x. Or let me solve first. Let me go with the solution. Now we are looking for something like a y double prime plus by prime plus cy equal something like this, right? Now it's clear that your a here, if you want to go here, and this thing is your c, right? This is your c, right? And this is your function f of x, right? So it is clear now that b is 0. So in this case, a is 1, b is 0, and c here is 1, right? I don't need b and c, but just to let you know that the b is missing. I know what is my a, I know what is my f of x. Just you need to be careful when you choose your coefficients. Now, how you solve this differential equation? This is the real solution, or we start here. Now, let me go with first homogeneous. So, general solution is of the form y equal to y homogeneous plus y particular, right? Now, to find your y homogeneous is like before. Then you go to the equation, replace y double prime by r squared, replace y prime by r, we don't have y prime, replace y by 1, right? You replace y by 1. And then you make it homogeneous, right? So this is the homogeneous. The homogeneous means you make that equal 0. And then you solve for r, you get plus minus I, right? This means that your alpha is there, right? Your alpha, or if you like, you could write this as alpha plus minus beta I, right? And from this you can get your alpha. Your alpha will be 0 and your beta will be 1, right? From this, I can go and build up y1. It is e power alpha x cosine beta x. Yeah? And in this case, I will have e power 0. and cosine 1x, right? Then I'm getting cosine x. Yeah? And if you go and build up your y2, if you go and build up your y2, it will be e0x sine 1x, and then you get sine x, right? And then you know what to do now. You get your y homogeneous is c1 y1 plus c2 y2, and then you get y homogeneous equal to here is c1 cosine x plus c2 sine x, c2 sine x. Yeah. Now, when you go to your y particular, now the second part is getting y particular. You go carefully to your equation here, and you have secant, right? And this is your f of x, right? This is not nice for us, not nice, yeah? Because it is kind of 1 over cosine. It is like dividing a polynomial of degree 0 over trig function, and this is not nice. Then I cannot go and guess my solution. I cannot go with indeterminate coefficient method. This will not work. Then I need to go with the second method. Which method? It is the variational of constants. So you change C1 and C2 into V1 and V2. Then your y particular will be, change this to V1. Let me write it like this. V1 of x. And here is y1 plus V2. And here is y2, right? Now there is a formula for V1 and V2. But before doing the formula, I know that for this formula, I need to find Wronskian, right? So since we're going to use Wronskian, so let me go and do Wronskian first. Y1, Y2. Then I'm going to have determinant of, you take the two solutions, Y1 and Y2, they are sine, cosine, and sine, right? Y1 is cosine, and Y2 is sine. And here you need to fill a 2 by 2 matrix. Then you differentiate this, differentiate, you get minus sine, and differentiate, you get cosine. And when you multiply, then cosine times cosine, you get cosine squared. And you multiply, so there's a minus here, right? And when you multiply minus sine times sine, you get minus sine squared. And then finally you get cosine square x plus sine square x. Yeah? And this is 1. And of course this will not be 0 because y1 and y2 are building the homogeneous solution and they should be linearly independent. Now you got the Wronskian. Now there is a formula for V1 that you need to memorize. What is this formula? V1 is, there is a minus sign, and here is a y2, here is f of x, here is a, and here is the w, right? W, y1, y2, and dx. Now let me write this here. So you're going to have minus. What is y2? y2 is sine x. What is f of x? It is the right hand side of the equation. It is secant x. And what is a? A is the coefficient of y double prime. It was 1 in our case. And what is the Wronskian? It is also 1. And here is dx. And now when you integrate this, you get something like, let me write it here. So secant is 1 over cosine. It is kind of, I'm just taking the minus inside, sine x over cosine x dx. Yeah? So in other way, or you can look at this as, this is g prime, right? And this is g, yeah? And this is dx, right? Yeah? And in this case, you have ln absolute value of g of x. Yeah? You don't need to add constant of integration. So you have g down, and it is derivative up. derivative of cosine is minus sine, right? G is cosine x. So it is clear that this thing will be ln absolute value of cosine. So I'm going to have ln absolute value of cosine x. So I got V1, now I need to get V2, and in V2, here's V2. V2, you're going to have a plus sign, and then here is Y1, f of x, and here is A, and here is W, Y1, Y2, and then dx. And in this case, you're going to have Y1 is cosine, and secant, and then A is 1, and Wronskian is 1, and then dx. Secant is 1 over cosine, so everything will be this thing and that one will cancel each other, and you get integral of 1 dx, and finally you get x, right? So I go now and build my y particular. So here is the y particular. Y particular is V1 Y1 plus V2 Y2, right? And then I know what is Y1, right? Let's keep this as Y1 Y2, right? And V1, I know V1, it is ln absolute value, ln ln of absolute value of cosine x, right? And Y1 is cosine x. And plus, what is V2? I got x, here is x, and Y2 is just sine x. Yeah? And back to our general solution, the general solution will be what? Y equal to y homogeneous plus y particular, right? Y homogeneous is this. So let me write C1 cosine x plus C2 sine x plus, you add the y particular, so this, all that thing here goes here, right? And plus here, plus ln absolute value of cosine x and cosine x, and then plus x sine x. Yeah, so this is the final solution for the differential equation. Yeah, so this is the general solution for our differential equation. Let me now change to another example just to give you the idea. Now, here is the general solution. Now I'm changing the question now. Here is another example. I'm gonna just keep the same question, which is y double prime plus y prime equal to, now I'm changing here and I want to put something like x here, yeah? And you could imagine that we have more, maybe x squared or whatever. So we have here a nice function, so this is nice, right? This is polynomial, poly. Yeah, so the question is asking, find the general solution. Now, here's the solution, just to give you an idea. So what should you do? So we know that general solution is of the form y equal y homogeneous plus y particular. Now, for y homogeneous, you can repeat the work before, and you just say r squared plus 1 equals 0, then you get r equal plus minus I, and then you get, if you like, y homogeneous equal to just C1 and cosine x plus C2 sine x. Now here is y particular. Y particular, now you can use guessing and indeterminate coefficient, and you can use the new method. So which method you're gonna do? So let's go and do option 1. Option 1. Option 1. Now what is option 1? So this is a polynomial, then you choose your y particular as a polynomial of degree 1, right? So you're going to have ax plus c, right? Yeah, and now you need to plug inside. Sorry, this is not y prime. This is y, right? I'm just repeating the previous question. So this is y, not y prime. So now you need to plug in for y. You need to plug in for y double prime, y particular prime equal to a, and then also y particular double prime equal to 0, and then you plug in the equation. So let me just maybe erase the question here. So then you're gonna have, this is y double prime is 0 now, plus y, which is ax plus c, yeah, equal to, on the other side we have x, right? And it is clear from this that you're gonna have a equal, the coefficient of x is the coefficient of x, you get a equal 1, and c, there is no constant here, then c is 0. Yeah, and it is clear that you get right away that your y particular should be ax plus c, and you discover that this thing should be 1x plus 0, then it is x. So you can guess the y particular very easily, and now you know how to build your solution. So your y should be y homogeneous, which is c1, cosine x plus c2 sine x, and then plus x, right? So this is the general solution. So this is the general solution. Now let me go with option 2. So what is option 2? So for y particular, I can go with option 2, or solution number 2. Suppose that someone wants to go with y particular using variational of constants. So he's saying, I'm going to go with v1 of x, y1 plus v2 of x, y2. So this means when you have a nice function on the right hand side, then you have two methods to find y particular. But I'm going to tell you that the method number 1, which is guessing, will be easier sometimes than the variational of constant method. So let me show you v1 now, v1 of x. It is minus integral of y2, and then here we have f of x over, if you like, a and Wronskian, right? Wronskian y1, y2. But I already calculated the Wronskian for y1, y2 from the previous example. So we have a minus here, we have y2 is sine x, and times f of x now is x, right? Yeah, and then 1 and 1, and dx. Now how are you going to do this integral? So this integral, you are lucky you're going to do by parts one time. Imagine that you have a polynomial of degree 3 or degree 4. Then how many times you're going to do integration by parts? Maybe 3 or 4 times. So for this reason, we first started with the guessing method, which is an easy method for nice functions. Then we went to a new method which says if you cannot guess, then go with variational of parameter and find your y particular solution. I can continue here if you like. So this thing, you can go with this integral, you go with u equal, so remember the word Lie, right? Lie. So trigonometric function and algebra, right? Algebra. So algebra, so this is for u. What is u? So algebra is the u. So this is u, and this is the this and that, right? This and that will be the dv, right? Then u is just x, and du will be dx, right? And then the other one is sine x, dv equals sine x, and dx, and v will be, sorry, I can take the minus with this, yeah? I can take the minus here with that thing, right? And then I'm gonna have that minus here. And when you integrate now, v will be what? Will be just cosine x, right? And now if you want, you have u times v minus v du, right? And then u times v is x cosine x, yeah? And minus integral of, what is v here? What is v here? V is cosine x, yeah? And dx, yeah? And in this case, I'm getting x cosine x, so let me write this. Let me write this here. Let me write this here. v1 of x will be just x cosine x, yeah? And then minus sine x, right? Because when you integrate this, you get sine x, right? And then I need to calculate v2. I will not write the formula because you know the formula now. v2 then y1, right? y1 and plus here. v1 y1, so y1 is cosine x, and then times x divided by 1 times 1 dx. And again, integration by parts, again you're gonna have this u and this and that is your dv, right? And from this I can write here that u is x, then du will be dx, and if you like, dv is just cosine x times dx, and then from this you get v equal to sine x, right? Yeah, sine x. And then finally this thing will be x sine x, yeah, x sine x, and then minus the integral of u here, okay, sine x, yeah, sine x and dx, yeah. And finally here what we got here, here is what we got. We got here x sine x, and when you integrate the minus sign altogether, you get cosine. Now let me write the y particular. Y particular will be, now in this case, y particular will be v1 and y1 plus v2 y2, right? And in this case, v1 was x cosine x, right? And minus sine x, and then you multiply this with y1, which is cosine x, right? Cosine x. And then you add to that v2, which is x sine x, yeah, and plus cosine x, and you multiply this with sine x, right? Now let me simplify, because this y particular is very complicated. Sometimes you may need to simplify, and if you multiply this out here, so you multiply this here, so I'm expanding the bracket, I get x cosine squared x, and here I'm getting sine x cosine x, yeah? And then I'm getting, if you also expand here, I'm getting x sine square x, yeah, I'm adding, and then I'm getting cosine x sine x, yeah, and I will discover that this thing will cancel that, and I have here something which is x cosine square plus x sine square. I can take the x common factor as a common factor, and I get cosine square x plus sine square x, right? And then this thing, I know that this thing is 1, right? And finally, I'm getting x, right? This is what we got in one step using guessing. This means that giving the indeterminate coefficient method from the beginning is something makes sense, because sometimes in a couple of steps you can get the y particular, not like this one. You need to do a lot of integration by parts, and then you need to simplify the y particular to get a very simple y particular. So If you go and now write your y, it will be y homogeneous plus y particular, and then again you put the y particular, you put the y homogeneous, and you are done. Let me solve another question maybe from the book. Here is another question from the book. We could go, for example, with question number 5. Question number 5 in the book. It says find the general solution. Find the general solution for what I'm going to show you. It is y double prime, or we may go with question number, I'm going to go with question number 7 here. Question number 7, y double prime plus 4y plus 4y prime plus 4y equal to e minus 2t, 2t times ln t, times ln t. So y double prime plus 4y prime plus 4 equal this thing, Now solution. Now look here, it is right away when you look at that function, it has a log here, then this will be variational of constants or parameters, So you cannot use guessing to find y particular. So right away I'm going to say my solution y will be, so this is the general solution, y homogeneous plus y particular. So the general solution is of the form, then you go with y homogeneous, right? Y homogeneous is, so you change to r squared, you change to 4r, you change to 4 times 1 equal to 0. Because you are going with homogeneous, then you need to go with 0, right? Then when you solve this, you get r plus 2 times r plus 2 equals 0. I don't mind if you go with your calculator. Here you will get just 1r. You get 1r, which is minus 2. From this, you get your y1 is e minus 2x, right? But for y2, because you have just 1r, then you need to make x e minus 2x, right? So you multiply by x. Sorry, here I forgot that my independent variable is t, then I need to change to t, right? So this is t, right? So sometimes the function f will tell you what is the independent variable, So, and here you need to multiply, of course, with t, right? This is just the independent variable. You should be careful when you choose your independent variable. Then from these two, I can build up the y homogeneous. It is just c1 e minus 2t plus c2, c2 t e minus 2t, right? And this will be the y homogeneous part, right? Now for y particular, I don't have any other option. So I have one option, it is not nice function, then I need to go with variational of constants. Variational of constants method, it says, hey, you need to go with v1, or let me write for you first, What is y particular in this case? It will be changing C1 and C2 to a new functions. V1, it is not to a new functions, to a function. So these are constants, now we have functions. Function of x, and then we know that e minus 2t, this one, and the other one is C2. We have no C2 now, V2. Sorry, it is V. Oh, again, it is the independent variable. So we have t and V2 of t, and then times t times e minus 2t. The only thing to find is V1 and V2. How are you going to find your V1 and V2? Let me keep this function because I need it, and I need to find the Wronskian, right? So let's keep these things. Let me write things here. So V1 of t will be we know the integral of y1 of t times, sorry, it is v2, y2, so 1, 2, right? F of t over a times the Wronskian, y1, y2, and then times dt. And now I know also v2 of t is plus y1 f of t over a times w of y1, y2, and then dt, right? Now if you want to find v1 and v2, you need y1 and y2, but I have y1 and y2, this is y1, this is y2, right? I forgot the equation here. I need the equation y double prime plus 4y prime plus 4y. Then it is clear that your a here, a is 1, and it is clear that this thing is f of x, right? Then I have the a, I have the y2, the y1, the f of t, and I don't have the Wronskian. Then I need to calculate the Wronskian for y1 and y2. So they are minus 2t and t e minus 2t, right? And in this case, you put them as they are, minus 2t, this is y1, and this is y2. You differentiate them, you get minus e minus 2t, and you differentiate this one, you get e minus 2t minus 2 minus 2t e minus 2t. And you know, you multiply, and then you get e minus 2t times e minus 2t, e minus 4t, right? And then you multiply also, you get 2t e minus 4t. So this is just coming from multiplying this. And then there's a minus in the rule, and you multiply this times that, you get minus 2 and t and e minus 4t. And then when you simplify this, minus minus, you get plus, right? You get plus here. And then it seems to me that this guy and this guy will cancel each other, and you end up with e minus 4t. Then here I have to go now with the rule. In the rule I have everything that I need here, so I can calculate v1 very easily. It is minus y2 was t e minus 2t, right? And then f of t is also e minus 2t ln t, right? This is f of t, this is y2, and divided by a was 1, and this thing, which is w, is e minus 4t, right? And then dt. Now it's clear for me that this guy with that will cancel that thing, right? And then I'm getting the following. Then I'm getting the following integral. So always it will be your ability to do the integrals, and how good are you in calculus. So this is, I'm going to go back to that word, which is Lie, and logarithm is the L for logarithm, then this will be your U, right? And that thing, this with that will be your dv, right? And in this case, I will not write everything. U times v, v is t squared over 2. Don't forget that minus. And then I'm getting u is ln of t times v, which is t squared over 2. So I'm doing integration by parts one time, and here is a minus in the rule, and it says you differentiate this, which is du, you get 1 over t, yeah? And then, yeah, so du will be 1 over t dt, right? So dt, this is the du, and then the v will be t squared over 2, right? T squared over 2. Yeah? So this thing is the v, this thing is the u, and this thing times the dt is the du, and this thing is the dv, right? You need to go to calculus and check the rule and memorize the rule for integration by parts. Then finally this thing with the 2 gonna cancel, and when you integrate you get something like the minus is coming here, right? So you get minus ln of t. I prefer to have the polynomial first. T squared over 2 ln of t, right? And then plus, here you get t squared over 4. T squared over 4, yeah? No need for constant of integration. And also, if you go and calculate V2 now, what is the difference? The difference is just this and the sign, right? And let me show you what we're going to get here. Here we are getting, I forgot here, maybe e minus 2t, right? E minus 2t now, yeah? And now this cancel with that, so the only thing is no t there, and here is a plus. So this is the y1. And now again, this cancel with that, this is v2. And in this case, I'm getting the integral of ln of t dt. Again, this thing is the logarithm, is u, and the dt with the 1 here is your dv, right? And again, your du will be 1 over t dt, and the v will be just t, right? And when you integrate this, u times v is t ln t, and then minus the integral of, this is the minus in the integral, v times du, then this times that, you get 1 dt, right? And finally, I'm getting t ln of t, yeah, minus t. Good? So this thing is your v2, and this thing is your v1, right? All what you need now is to go and write your y particular. So here is the y particular. It is v1 y1 plus v2 y2, right? And v1, we know that this is minus t squared over 2 ln of t, and plus t squared over 4, yeah, times y1. y1 was e minus 2t, and then plus v2 is t ln of t minus t, right? And then times here, times y2 is t e minus 2t. So this guy here is that guy, and this guy here is that guy, and this thing here is y1, and y2, right? Then you go back and now write your general solution. The general solution is just y equal to y homogeneous was c1 e minus 2t plus c2 t e minus 2t, and then here plus, you take that thing is minus t squared over 2. By the way, you may simplify things, right? can I simplify this before doing anything? So here kind of I'm getting t squared. So if you just multiply this here out, what are you gonna get? So it seems to me that this thing can be simplified. You get t squared e minus 2t, and here minus t squared over 2. Then you get t squared over 2 ln of t, yeah, and e minus 2t if you like. And the second thing is here t squared minus here t squared minus t squared, then you get kind of minus 3 over 4 t squared e minus 2t. So I can add here the solution in the following way. So here is the solution. It will be something like plus t squared over 2 ln of t minus 3 over 4 t squared, and here e minus 2t, right? So this thing is the general solution. I'm not 100% about the calculations here, but I'm sure that this thing will simplify. Let me go t squared minus t squared over 2, t squared over 2, and then here t squared over 4 minus t squared, then you get minus 3 over 4 t squared. So this is the simplified y particular, this is the y homogeneous, and this, the addition of them, you get the general solution for the differential equation given in this question. So this question cannot be solved in two methods. It can be solved only using variational of parameters or variational of constants. I think it is an easy section. For this reason, I'm not solving more questions on this, because the solutions will depend on your calculus, your ability to do integrals in calculus 1 or calculus 2. By this, we reach the end of today's section. Thank you for joining me in this section, and have a great day.